All right, number 4, we want to determine if Rowley's theorem applies to the function below on the interval, and we're going to give the points that are guaranteed to exist. All right, we're given f of x equals 9 minus x to the 2/3, and we are on the interval -1 to 1. All right, so first I'm going to verify that both of these are the same value. So we're going to look at f -1 and see if that's equal to f of 1. And so that will give me 9 minus, and this will be the cube root squared. Okay, so and you can do either first. All right, so if I square -1, it gives me a +1, same thing, so those will be the same. The cube root of both ones will be 1. 1 times 1 times 1 is 1. So we're basically getting 9 minus 1 here, and 9 minus 1 here, and we get 8 equals 8. So both of them are the same. We're good to go there. And that being the case, we will have a critical value in here somewhere. So now we will find the derivative. So derivative of a constant is 0. And then we're going to multiply by 2/3. So minus 2/3. And then subtract 1. So it'll give me a -1/3. And when we set this equal to 0, we can multiply by this constant, and so that will give us 0 equals x to the -1/3, which is basically saying one-third, which is a cube root. So basically we're going to raise both sides to the 3rd power, and we get 0 is equal to 1 over x. Or when I multiply by x, we get 0 equals 1, so we don't get a value in between here where it is equal to 0. So it does not apply because we don't find a point that's equal to 0. Number 5, we're going to determine if Rowley's theorem applies. And so we're going to just go with the assumption, I think every time these 2 points have been equal. When you plug in a -AU squared, you get positive AU squared, and you get positive. So these are going to give us the same value. And we're going to work from there and find the derivative and set it equal to 0. So I'm going to start with h of x is equal to e to the x squared. And we are on the interval -a. And a could be anything to a. And we'll find the derivative. So derivative of e to the x, we're going to use the chain rule, is e to the x, whatever the power is, times the derivative of this, which would be times 2x. And we're going to set this equal to 0. And then we'll have two factors, e to the x squared equals 0 and 2x equals 0. So in this case, x equals 0, and in this case this will not equal 0 at all. Even if we plug in a 0, we get a 1. So e to the x just kind of hugs the axis and curves up. So this one will not be equal to 0. So we get 1 when x is equal to 0 will be the 1 critical value.